Right, so Kaisa, over to you. And so I don't forget to introduce you. You are the chief methodologist at Positium, and we're going to hear from you for the roughly next hour. Right, thank you so much, and over to you.
Hello, everyone from my side as well. As Sophie already mentioned, we will be talking about meaningful locations today, and also how to use them in the context of usual environment and employ these concepts for producing mobile phone data-based statistics. So what we will do today, we will go over the definitions of meaningful locations, usual environment, and country of residence. We will also touch upon a little bit about the data requirements for these meaningful locations when we want to detect them from the mobile phone data. We will talk about detecting these locations from the data and also how we can validate our models that detect these locations. We will talk about what is usual environment and how to define it in the data, and also briefly about the concept of country of residence and how to identify it. And last but not least, we will talk a little bit about also limitations and ethical considerations. And after that, we will move on to the coding exercise that I will show you. Right, so let's move on. First of all, about the definitions. So how do we define meaningful locations? So meaningful locations are regularly visited places that have any kind of a meaning for an individual. What I would like to say is that these locations typically are our home, our work, maybe our friend's house that we visit very often, school, university, and they kind of happen and exist in our lives, having a very important place based on the frequency we visit it. And these locations, if you pull them together, as we have done in this blue box, they form your usual environment where you conduct your daily activities. So you move around between these places, and this environment around you is something very familiar to you that you inhabit on a daily basis. Now, we can also move out of these usual environment, take trips, go abroad, travel in the countryside, in our own country that we not necessarily frequent daily. So in these situations, we might consider ourselves being a tourist. And last concept that I would like to touch upon on this slide is country of residence. So if we talk about the country of residence, we typically refer to a country that we have lived in at least a year. And this is a place that basically hosts your primary place of residence. So these two concepts are very frequently used when we use mobile phone data for producing different kinds of indicators. And these kind of indicators, they feed into different use cases. We can talk about producing official statistics. We can talk about producing indicators for transportation planning, urban planning. You have heard already about crisis and disaster management and how to use mobile phone data there. We can use these indicators that are produced based on these concepts. We can use them for tourism statistics or using them in epidemiology. So all of these use cases are definitely very strongly tied to these three concepts. And what are these data requirements that we actually need? It seems like there could be many, but typically when we work with mobile phone data, the minimum requirements is that we would be able to have an understanding of temporal and spatial patterns of phone users. And The attributes that typically provide us this type of information are user-related identity, such as user ID, subscriber ID. It is also a timestamp of the event, user-generated event, and also the location location for the event. So location typically is then the cell tower location that can later on be interpolated into a probabilistic location of the user. But typically we operate around these three main attributes, and therefore detecting any kind of location semantics from MPD typically focusing on identifying characteristics that relate to usage of a single cell or cluster of cells where defined time periods such as day, week, month, or year for phone subscribers. So in this particular location, what are the characteristical patterns of particular subscriber, how they frequent it, what times they are present in this location. So all of this gives more of a semantical information for us to work further with this data. So that means that when we start to sort of look into detecting meaningful locations, so we could ask a question, is the location of a mobile call something special? Or it is just another location of another activity that has maybe no significance to us? And in order to have those significant locations, we need to have or need to be able to detect visitation regularity and frequency over time. And also important concept here is subscriber identity consistency, meaning that we would need to be able to detect the same person over a period of time. Otherwise, for example, we wouldn't be able to assign a long-term home for them if we would need, as per our use case. And as I already mentioned, the requirements for this type of temporal coverage can be really use case dependent. So for example, if we define our use case being understanding commuting patterns, then shorter time periods could already be offering useful insights. But if we want to produce official statistics and population statistics, then we typically adhere to some kind of definition, such as place of permanent residence that is defined over the course of 12 months, for example. So in this case, our data requirements are much stricter in terms of temporal coverage. So then we don't operate on a couple of days. We really need to have, for example, 12 months worth of data in order to be able to detect such a meaningful location for a person. Now, if we talk about meaningful locations, then they are quite often also referred to as anchor points. Anchor points because these are the places that sort of form as a gravitas into our lives. This is around which our life kind of revolves. And if we talk about what type of anchor points we are able to actually infer from mobile phone data, we typically talk about identifying home anchor, which is the most important meaningful location that we can detect and feeds into many of the use cases, alongside which we also talk about work time anchor point. For these people who might work and live in the same location, which is after COVID, not so uncommon, we could talk about multifunctional anchors. And many of us also have holiday homes, maybe parents that we visit very often. So we could talk about secondary home anchors or secondary work time anchors, because we might have a couple of places where we actually frequent because of work. And then for these locations that we might frequently visit, but maybe they don't own any kind of typical characteristics of visitation pattern, we might want to define these types of locations as simply other meaningful locations and not label them with any other label other than this. This is just a meaningful location, but that's about it. Here, On the right side, you can see also how a city could look like during the nighttime, the city center, and how it could look like during the daytime. And it already cues in the approaches that might be used in order to detect or distinguish work from home. So let's look a little bit deeper into home location and how would we want to detect it, some of the approaches that might be used for that. So first of all, let's try to think about how might we actually characterize a home location? Typically, and I know it varies from country to country, I'm talking here, for example, about Estonia. Our typical workday starts around 8 o'clock. So if you look at the left side of the graph, you see a home location and the record counts for a subscriber at home location. You can see that at the very beginning of the morning, you see a little peak there, and then the record counts disappear from home location and reappear again around 5 or 6 p.m. So this is a very typical pattern. And if we look further, then again, for the weekday rhythm, we might see actually more presence at home during the weekends because we simply have more time to spend there. And some people choose to spend a lot of time at home during the weekends. It doesn't necessarily have to be like that for everyone, but this is the typical rhythm. And we can later on talk about what it means if you are actually a shift worker, if you might, for example, work during the weekends. So obviously these algorithms need to account for that somehow. But in general, the patterns are kind of characterized typically like this. And then let's also discuss a little bit about long-term home. So you might already infer from the previous slides that we might have a holiday home, and we also might use it, for example, during holiday seasons in the summer. Typical Estonian might spend a month or two at their holiday home, meaning that they leave their permanent place of residence to live in a different location for a couple of months. And in this case, we talk about short-term mobility, short-term migration, but we might still want to define their permanent place of residence where they actually reside over the course of years. So in this case, we might also want to look into the prominence of a home location over the course of more than 1 month, for example. Now, here is a little review of different home detection algorithms that we might see in the literature. Typically, these are some kind of decision rules, different statistical and heuristical methods that use either temporal variables or activity variables in order to define a home location. And as I already mentioned to you, then typical variables for temporal types are day of the week that could signify one location, a particular location being a home location. Or you might want to define resting or working hours. So resting hours normally being hours after 6 p.m. in Estonia, for example, up until 7 a.m., and so on. And typically in these algorithms, these are generalized, meaning that the algorithm uses these variables and their values for the whole set of subscribers. They don't distinguish between different types, but some algorithms, and there is few, might approach it as more of an individual level, meaning that they try to detect these inherent patterns in each individual and define the resting and working hours for them. So if we move on to activity variables, then frequency of activity or distinct days of activity or standard deviation of activity start times might be the ones that help out in determining the location of a home. So the more you spend time at a location, the higher it is in the ranking of basically in the locations when you rank them by the number of days you have been present there, it's more likely that you actually are looking at a home location because a person, this is the most visited location for them normally. And also, you have already heard about continuity models. So duration of stay could also be used here as one of the variables might help you to detect presence of a home location. And on the right side, you can later on see the references for these research articles that have been quoted here if you're interested in doing so. However, you have a lot of these different approaches out there how to detect a home location. And not all of them are equal in this sense, and they might behave differently. There was a very interesting validation study done that was comparing different home detection algorithms to census counts at cell tower level in France. And actually, the findings show that the choice of criteria that we just went over quite significantly influences the results of these home detection algorithms, up to 40%. And on the right-hand side graph, you actually see that if we start comparing two algorithms to each other, you see on the graph, it represents how similar these are. So the value on the y-axis actually represents the ratio of users to whom the two algorithms detect the same home. So some of these algorithms are very well aligned. Some of them differ quite a bit. So it's important for you to understand what you seek for. You understand what the algorithm does, and does it fit your majority subscriber profile that you intend to identify homes for. So typically, with these home detection algorithms, one thing that goes alongside home detection is work time, location, and its detection. And why I mentioned work time, not the work location, is because mobile phone data typically allows detection of work time location, as we cannot infer from the data facts about employment. So that is why if we detect a work time location, it might be school, it might be, for example, a kindergarten, if the kid has a phone and uses it during this time they've spent there. So that is the reason it's important to understand the conceptual difference between work time and work. So it's especially important when you start disseminating any kind of results and make it very clear how to analyze these results, how to further use these results when these go to different kind of data consumers. Because if it's listed as a work location, it already tells a different story and could be potentially impactful from the analysis perspective. Now, if we now put the similar graphs as we did with the home location detection, so work time typically kind of counteracts or is acting just as an opposite to home location, meaning that when we are spending nights at home, then the daytime typically we spend at work. And also typically we talk about work time as something of a Monday to Friday activity. But again, it's typically, and Not all of the work or employment activities necessarily follow this pattern, but this is just one example that is being used. And here is another list similar to the home location detection. I'm not going to go too deep into this because, as I already mentioned, work time location detection usually goes alongside with home. They are detected together. So the table here is pretty similar to the one I already showed. So you can go over here later on and look into them, but we typically still talk about resting and working hours, weekdays, weekends, frequency of activity, distinct days, standard deviation, etc. So if you look into these tables, then just look into them together, compare them. Look into the articles and you will definitely find the very interesting work that is being done in this field. So one important thing to consider is the local context when you start detecting meaningful locations. So because success of home and work time location detection can be affected by several external factors, and those factors can be influenced by local context. For example, one of these things is seasonality. As I already mentioned before, holiday season, if you start using mobile phone data for detecting homes, and maybe you have only a very short period of data available, you might consider that during a holiday season, if this short period of time falls into holiday season, you might not get an accurate picture of population distribution and be able to generalize it for the whole year. That is because, for example, in some countries, and again, I am from Estonia, I can bring an example from this country. We have this very typical pattern of leaving our permanent places of residence for summer to some other holiday home that we like to spend time in. So if the time frame that we want to measure the population distribution would fall into that time, it would actually look pretty different comparing to the time, for example, in October or November. Typically cities during summer lose residents, and some countryside areas actually gain these temporary residents. Another thing to focus on is, of course, phone usage patterns. For example, if the country you work in with the mobile phone data has a very kind of high number of people sharing a phone, then we might not necessarily be able to accurately detect a home location, let alone we actually work with two people under one subscriber. So there can be mixed patterns, and this already creates inference for our home detection algorithm. And again, if the country you work in with the mobile phone data, a lot of people actually, for whatever reasons, might use phone irregularly, or there are regions in the country that might see irregular phone usage due to power cuts, and maybe bad reception, etc. Then using any kind of short time frames for meaningful location detection might actually leave these people out because there's not sufficient data to support detecting home location for them. So in this case, there is a higher chance, if you use longer time windows, that these people also get a home location. Now, we also mentioned at the beginning that how do you then know that if you have chosen an algorithm and use that algorithm and maybe tune some parameters in that algorithm, that it actually works the way you intend it to work. So there are different ways of approaching this. One of them is small-scale ground truth or individual level validation. So this validation data, either you conduct a survey or there is already existing survey that you can use, where you have user addresses or a user or a person has been asked their home or work location, and you're able to also connect the survey with the users in the data. So usually it's a consent based. So these users give you consent that, okay, we can identify you from the data and use this data for validation purposes. So this is a very important aspect to note here. So once this consent is received, you can compare the results of your algorithm with the actual home locations that the people, or work time locations the people have noted down in the survey. So this type of approach is typically very good for algorithm tuning and accuracy measurement. Another approach could be high-level comparison or aggregate validations. So this is already when you have your population counts, for example, you know what the population distribution looks like based on the mobile phone data. And you can compare these results with census population and or, for example, commuting data statistics. So you know how well the two result sets correlate to each other. So basically it's a sanity checking your results. And something that is more rare, but I just wanted to bring it out still, is large-scale individual level ground truth. And this is done normally using GPS data and labeling the locations detected based on the GPS data. So there are a couple of examples of this type of validation done, but it's obviously much harder to set up such an experiment. Now, once we have reached to a point where we have identified these meaningful locations, we have our home location, we have our work time location. So then the next thing is to construct user environment around this location. So the set of these locations, these very important locations in a person's life, actually forms a geographical areas in which this person conducts their daily activities and in which we might consider them a frequent visitor. They are not a tourist in these areas of user environment. So in order to detect such an area, and in this graph, this area of user environment is colored purple. You see a lot of these places inside this. So naturally, as I already mentioned, for defining such an area, we need these anchor points or meaningful locations. We also need to understand then what is the minimum or what is the building block for the user environment. We might talk about different levels of administrative units here. So this inherently defines whether if my points that will all fall into one city, the user environment is this city, or maybe we want to have a larger, more looser definition for user environment, and maybe we will define that our user environment minimum building block is actually a state level, meaning that any kind of activity that is happening inside the state where the city is located might also be considered a user environment. And it's again use case dependent and depends how you might want to yourself inside the NPD project you work in define it. So, and naturally, for the algorithmical reasons, we also might want to define then when a person is inside the user environment and when not. So again, this might be a spatial query that checks whether you fall in this minimum building block of user environment, or maybe you want to define it as distance from some type of meaningful location. Now, here, let's stop for a minute. And I would actually like to ask a question from you. So if you look at this map of different regions, you notice that there are different meaningful locations noted down in this map. There is home location, there is work time location, there are other regular anchor points here. So let's assume that there is a person who travels from region 100, which is here, to region 105. And on the way, he also visits this region 113. So how would you actually define this person in region 113? So I will give you a minute to answer this. So again, when you answer this, you can think about the minimum building block and how would you define it. We can later see that there might not be a right or wrong answer here, but let's see if somebody decides to answer this question. Okay, I already see a couple of answers popping up. Let's wait just a moment more if anyone else wants to answer, and then let's move on to discussing the answer. Right. So I see all of you have basically identified this person inside the region 113 being either a visitor or a tourist. And based on how we have visualized this, then yes. Let's go to another slide. So we all made an assumption here that the smallest unit for usual environment is defined here as a region. And since none of these points fell into the region 113, then obviously we can define this person being in this region either a tourist or a transit visitor, as somebody said. Again, being a tourist or being a transit visitor, I would say in the case of MPD is also a matter of definitions, how long you might want to spend time in the region. So yes, I did say that they went through the region 113. I didn't say how long they stayed there. So both are correct in this case, either a tourist or a transit visitor, we don't know. But again, I would like to highlight here that if, for example, if this region here would have had a parent region that would encapture all of this region inside it, then we would have defined this person inside this 113 also as a frequent visitor, meaning that it would be part of their usual environment, but only if there would be a parent region that is a minimum building block for the usual environment, for example, in this case. So if we now put this usual environment concept aside for a moment, let's talk about identifying country of residence. And according to the official definition, country of residence is the country where the person spends most of their year. And there are cases, for example, if you have access to more than, for example, domestic data, you have also outbound data, which signifies person's presence in a country other than the country of residence, you might be able to get facts that this person actually spends more time in some other country than that, the default country that we work with. Or similarly to inbound, if typically we use inbound data for detecting tourism visits, but if there is someone who actually is present in inbound for a year, then we could redefine this person as a resident of this particular country that is related to this inbound data. So for that, we use typically a window of 12-month window to check for the maturity presence in a particular country, and we might want to redefine it according to that. So, for example, if we look into this graph, and let's say we have combined here domestic data from France, and then we also have outbound data alongside, which we see that this person also goes to Italy. And here we see that there's nothing wrong. It looks like this person from France spends most of the year in France, but then on some months they might go to Italy, for example, for holiday reasons. Here is another case where we see that actually there is a person that's from France, but in outbound data, for example, we detect that actually this person spends a lot of time in Italy. And we can even clearly state when we look into the full data scope that is available to us that yes, at the end of the year 2024, it looks like their country of residence has actually changed. And in the MPT data, we might want to then redefine the country of residence based on that. Another thing I would like to maybe briefly touch upon is that if you don't have access to the full data scope, so maybe you have a MPT project that deals with these continuous data updates, for example, you receive new data each month. What happens then? So in this case, we start to move every month, we check where this person is. We see, okay, person from France, their permanent, their country of residence seems to be in France, they went to Italy. We check it for a couple of months, go on, up until we actually receive the 7th month of data. And now we are actually, according to the definition, able to say, but okay, it looks like they changed the country of residence 7 months back. But this confirmation can only happen after we have these facts to support that the majority of year they have spent in Italy now. So there is a question from the project point of view and the use case perspective as well, whether we want to retroactively change the already maybe published data and some of the values there, or how do we treat such cases with these continuous updates. And again, I say it's more or less the use case dependent, and between the agreements, it's about agreements between the parties that are involved in the project. In some cases, it's not advised to adjust the indicator values. In some cases, you might want to do that once you have more facts to support the corrections in the values. And now my last slide before we go over to the notebook coding exercise part. Let's briefly touch upon the limitations and ethical considerations of using mobile phone data. So obviously, in general, processing MPT data for any kind of statistical purposes shall be subject to appropriate safeguards, privacy best practices, and also relevant laws, such as GDPR in Europe is to protect the rights and freedoms of the data subject. Now, in order to use this data, you must make sure that you are protecting the individual that is inherently kind of giving this data to you to use. And in order to do that, there are a couple of evaluation methods that you can use and are listed by the European Data Protection Board. These are singling out, which means that if your data fails to pass the test of singling out, meaning that you are able to isolate an individual from the larger group of data or larger group of individuals based on some of the attributes that are present in the data. This is already a red flag for your use case. Another thing is linkability. So for example, if you're able to take one data set and link it to another data set and infer some information about the user through that, is another red flag. Another test failed. And then there is inference, which means that if you are to some probability able to deduce some kind of information, not necessarily singling out an individual, but there is a large probability that this person that you have identified in the data is this person that you think it is. So this is another red flag raised. So there are different tests to make sure that your data set and your project follows the best practices for the data protection. There is guidelines published for that you can look into. So we won't go too deep into this here, but just to make a note of that. And once you obviously work with statistical indicators, producing official statistics, and there is also a very good article that goes over the fundamental principles for official statistics and what are these principles to ensure trust in statistics based on this novel and new experimental data sources. One of them is necessity and proportionality, which means that there should be a clear need for using this data. Professional independence, which refers to that an NSO, National Statistical Organization, actually is free to make decisions about the methodology used for processing this data, for example. Already mentioned privacy protection. We discussed this already. The fourth one being the commitment to quality, meaning that we still subject this type of statistical product also to rigorous quality assurance frameworks that make sure that it's a good quality data that is being disseminated. And also we talk about international comparability, adhering to international standards that might be overarching your different use cases, be it tourism, be it population statistics, etc. So as long as we're able to use this data and also compare it internationally with another set of produced statistical indicators, for example. So it's not isolated use case, but can play into a larger group of use cases from different countries. So now let's move on to introduction to practical exercise. For that, you could go to GitHub. There is a link here, and there is a notebook called Meaningful Location and Usual Environment that we will go into now. So the notebook, as the previous ones were, is in Google Colab, and you can run it cell by cell. For the aim of this notebook, it is to detect or kind of apply a very, very simple algorithm or approach to synthetic data set and understand what different parameters might do, how the results might change when you play around with the parameters. And at the end, we will also try to assign this user environment label for detected meaningful locations. So we first start with importing necessary modules, as always. I won't run this notebook because it might take a little bit too much time, but I have pre-run it, so we'll see a little of the results. The next thing we do after importing modules, we go into and import the data. And for this exercise, we use 3 different data sets. We use the cell location data. We use the events data, these so-called user-generated events. And additionally, we use the diaries data, which you could think of as a ground truth data set. Think of them as travel diaries. So this helps us to understand how far off are we with our home or work detection, because this data sets has assigned these synthetic users their synthetic home and work location. So this is something that we can look into. So the data sets look like this. And once we have imported them, one thing we will do, so this notebook will run the meaningful location detection for all of the 1,000 users in the dataset, but for a deeper dive, we might want to work with a couple of predefined users to look into their results. So this part of the code will help you actually to define this. You can either choose a random user or you will use a predefined user. So there is a tip here that says that a couple of user IDs that you can play around with, and some of the exercises or questions in this notebook are also about these users 89 and 802. So once we have predefined our couple of users that we want to work with, we will start investigating the target population. And we do that based on the travel diaries data. So since we know nothing about this synthetic society, before we start playing around with the algorithm, we want to maybe get more acquainted with its inherent rhythms and how people might behave inside this synthetic society. Typically, in any real world use case, we would already maybe have a, for example, time use survey, or we just, we live in this country and we understand how it works. So we have a good starting point. But here we just work with generated data, so know nothing about these users. So in this data, this code will actually run so that it produces a couple of plots that you can investigate. And then we scroll back a little bit to the checkpoint exercise. There are a couple of questions that will ask you to study these graphs and understand what are these rhythms that you see there. So, and to keep these in mind when you start working with the next exercises. So moving on very quickly to this bit in the code that deals with now calculating some characteristics for each of the location for each users inside a month time window. So each location gets for a particular subscriber inside a month time window will get count of events, count of distinct days a person visited this location, number of weekend days they were present there, distinct days during the working hours user was detected in this location, and also the nighttime hours. So these are these general variables that we already went over when we discussed this during this theoretical part of the session. So once you have run this, this will be calculated for the whole dataset. But as I said, we will also have a user defined that we work with. We already see here their most important locations and or all of their locations, and what are these characteristics that kind of characterize this location. So once we have that, we have successfully run it, we can move on to classifying locations. There is a function, Python function, that will do that, and it has a set of parameters. These parameters are defined here. You can study them and then do the exercise. So these parameters basically operate on top of these previously defined characteristical variables that we calculated. So there is a checkpoint exercise that asks you to play with these parameters. And you can do that in the code. When we go scroll a little bit down, there is a section called play with the parameters, and these are a set of values for the same parameters that are defined in the beginning of the exercise. So you can check the definitions, first run this cell with the default parameters, and then there is a tip for you there also to in which direction you might want to change some of the parameters, but you can just choose your own direction to take basically. And just once you have changed the parameters, and I suggest you to do them one by one to see the influence and the impact of each change and each parameter, you will get, first of all, counts of meaningful location for the whole data set. So you see that there is more than 55,000 locations that didn't register as meaningful. There is 11,000 in this set that is labeled as other, and then there's home and work time basically. And these numbers will start to change once you play around with the parameters. So, so do that. And here you can see the results for particular user we have selected for ourselves. And each of these locations is now already having a semantic label. Once you do that, you might also want to actually look at these users from a map. So how far I'm actually with the ground truth with my detection. So this part of the code actually generates a map for you where you can actually see for this user. So we have these diary entries. This is the ground truth set. You see here the different labels. And this is the label data, which is what we did already now. So you see that we have identified home location, and the actual home location from the ground truth set is here. So you can play around and see how this changes with the different parameter values. And then maybe you saw already when we detected home location, then for this particular user, we have multiple home locations detected because multiple cells acted as a proxy for home. And for that reason, typically at the end of the day, we might want to define one main home location. So there is a code part that will do that. Select one main home, and typically it's done by using the highest ranking location that is labeled home, meaning that you have been present there the most days compared to the other home location. And then there is a checkpoint exercise here where we use one particular user who has actually changed home location during this time. And now once we apply this algorithm of defining one home only for this particular month. So this is more of I would say use case dependent question, or just a thought exercise to think like, what would you do if that would happen? Like you have this time window of defining home for a month, but inside this month the person changes the home. So just to think a little bit of these use cases as well. And then once we have defined this one main home and work location, there are attributes, is primary home, is primary work. We can basically assign user environment label to the events data. So all the events that are related to any kind of detected meaningful location basically are labeled as being part of user environment. And you can see that result also on a map. For example, for this user 108, We have, let's show you the legend as well. So we have here usual environment as blue, and also we have those locations that are not considered part of regular activities, they are red. So you can now start thinking about this checkpoint exercise of actually now if we have this type of labeling, then how to move up from there to use the administrative units as the building blocks. So with that, we have reached the end of the notebook. I hope you will find it interesting to test it out. Yeah, that is it from my side. I will just stop sharing and Sophie can take over.
Thank you so much.
Thank you all for listening.
Great. Thank you so much for your time, Kaisa. And everyone, thanks for your attendance, and we'll see you next week. Thanks. Bye.
Thank you. Bye.